Dear students, now we are going to study about counters. A counter is a digital sequential logic device that will go through a certain predefined states. It is frequently required in digital computers and other digital systems to record the number of events occurring in a specified interval of time. The counter counts from 0 to some number, that is 2 to the power n minus 1. If the counter counts from 2 to the power n minus 1 to 0, then it is called as binary counter. There are two types of counter, asynchronous counter and synchronous counter. Asynchronous counter depends upon the clock pulse. Asynchronous counter is also called ripple counter. The first flip-flop is clocked by an external clock. All the subsequent flip-flops are clocked from the previous flip-flops. The asynchronous counter is also called ripple counters because of the way the clock pulse ripples its way through the flip-flops. A counter may count up or count down depending upon the input control. When count up, the sequence is 0, 1, 2 and so on. When counting down, the count sequence goes in the opposite manner, that is from high to 0. Let us see an example for 2-bit binary counter using JK flip-flop. We are using just 2 JK flip-flop where the first flip-flop is triggered by a clock pulse and the second flip-flop depends upon the clock pulse depends upon the output of the first JK flip-flop. See the arrangements. There are 2 flip-flop, JK flip-flop. The input to J and K is commonly connected to 1. According to the truth table of JK flip-flop, if the 2 inputs are high, the output will toggle to the previous state. That is, if the previous state is high, the current state will become low. The output will be the complement of the previous state. So that is why this condition is used in ripple flip-flop. So that is why we say ripple counter. Let us take this ripple counter and find out its timing diagrams. Both the input is given high, the output is connected, first flip-flop of the output is connected to the clock pulse of the second flip-flop. See the timing diagram where the clock is given, clock input is given like this. Each pulse is numbered 1, 2 and so on. We will see the output of the first flip-flop. This is the output of the first flip-flop. When the first clock pulse is going down from high to low, the output Q0 is high, going high. Then in the second clock pulse, the output reverses its direction. It comes down and so on. In the next flip-flop, the second flip-flop or output is, it depends on the output of Q0. So, when the clock pulse is going from high to low, the output of Q flip-flop 2, that is Q1, changes its direction. It goes high and vice versa. So from this we find out in clock pulse 1, the output is 0, 0. Clock pulse 2, the output is 0, 1. When 3, 1, 0. Clock pulse 4, it is 1, 1. So in this way, you can see the counting. You have 0, 0, then 0, 1, 1, 0, 1, 1. So it is for a 2-bit JK flip-flop, you have counting starts from 0, 1, 2 and 3. So that is why we say this is asynchronous counter. It is up counter because the counting goes from 0 to high. Likewise, you apply the same diagram, the timing diagram and the trick table for 3-bit JK flip-flop. Thank you, students.